Hi everyone, welcome to this edition of Career Insight. And today it is my privilege to bring to this show Sasha, who is a genetic counselor. And so we'll be talking about what it means to be a genetic counselor, what it entails to even get started as a genetic counselor. To be honest, before I met Sasha, I never knew anything about genetic counseling. I didn't know it was a thing. So I suppose there are a number of people like myself out there who have never heard about it or have heard about it but do not really know what it entails and how to even get started if you're inspired to become a genetic counselor. This is where we talk about that in experiential pattern, talk about how she made her way to becoming a genetic counselor, what kind of skill sets, what kind of experiences she's garnered over the years, and what it really means to be a genetic counselor. So stick around and follow us in the deep dive conversation around this topic. Welcome on board, Sasha. Thank you for being here.
No problem. Thanks for inviting me.
How are you doing today?
Yeah, very well. Thank you. How are you?
Good. I love the hair.
Thank you.
So Sasha, if you wouldn't mind, can you just tell us a bit about yourself and maybe throw in a fun fact about you?
Fun fact. So my name is Sasha Henriquez. I am born in the UK, raised in East London, which is, by statistics, often described as one of the most diverse parts of the world. So in a borough called Newham, which is poor and diverse. So I grew up in East London to parents who are Jamaican immigrants. And the fun fact is that my surname in Jamaica was introduced by Portuguese Jewish people into Jamaica in the 1800s. There you go. I guess that's a fun fact.
Interesting. That sounds very interesting. Did you know that I thought Henry? How did you pronounce that?
So in Jamaica, another fun fact. In Jamaica, because we don't speak Portuguese, we pronounce it as Henriquez. But in Portugal, where it's the name of their first king, they pronounce it very differently. So they pronounce it Honriche, I think.
Okay.
But people often expect it to be Spanish or French, and so they pronounce it either in a Spanish or a French way, and it just isn't. So Brazilians also have the name as well, so because they speak Portuguese. So.
Wow, interesting. Because I would have pronounced it neither of both ways. I would have pronounced it as Henrix. That's how it sounds in my head. But thank you for making that clarification there. Would you mind telling us about what you do as your current role?
Okay, so currently I'm a PhD candidate with Wellcome Connecting Science, Wellcome Sanger and Cambridge University. So I'm currently doing a fellowship that is looking into structural inequalities around genomic research. So in particular, I'm looking at how genomic researchers categorize their data when they are using either race, ethnicity, or genetic ancestry. So which of those they use and when, and whether how the use of those improves inequality or embeds inequality. So it's kind of generally around the social justice, equity, and fairness of how genomic researchers are using data that describes humans, so their human population data.
Wow, that sounds very amazing, because I mean, these are words that people throw around every now and then. But having people actually at the forefront pioneering research to see how this is actually done in practice is very inspiring, and I'm happy you're doing that.
Thank you.
But I understand you have a track record of being a genetic counselor for your PhD. Do you want to talk about that experience? How did you get yourself into genetic counseling in the first place?
Okay, so I have a long track record of working in roles that align with my values, and so I have always had values around kind of empowering people to make decisions, and values are kind of around equity and fairness. And so my career started as an undergrad. I did biological sciences, and I knew in doing my undergrad that I wasn't going to be a lab scientist, that I was passionate about science, but what I found was the bit of science that I wanted to be involved in was helping people to use science in a way that would make a difference for their lives in I guess in a feedback loop that's a lot smaller, I guess, than doing research. And so I then wanted to be a science journalist. And so I wanted to work in science in a way that was about communicating science through kind of radio, print, TV, whatever. I kind of hadn't decided. And so I did a master's after my biological sciences in Manchester. I did a master's at Imperial, which is a science communication master's, which still kind of runs now. And I keep meeting people who work in all different bits of science in different ways, who have done that master's in science communication. So it talks very much about kind of the ways of communicating science through different media and what kind of messages you may or may not want to be instilling by communicating in different ways and in different circumstances. So then after I did that, I then worked in the private sector, and they produced conferences around science. So it was more kind of working with professionals in science and bringing in other professionals and organising conferences. So using my skills to write copy and write conferences and research what were the current scientific conversations in different areas and bringing those people to have conferences. But I wanted to work more with the public, and so I left that role and then moved into the charity sector. And so I worked for charities and produced information for charities, which was kind of medical or scientific information that was applicable to families who were affected by those things. So I worked in mental health charities, and I worked in charities where families had children affected by long-term or chronic conditions. And so in doing that work, that's kind of where I discovered what the role of a genetic counsellor was. And so I, by chance, met somebody at an event. They told me about the role, and I was like, actually, that really aligns with the things that I think are important and the skills perhaps that I already have. And so I then did another master's in genetic counselling to become a genetic counsellor. And I, from the very beginning of working in genetic counsellor, I did cardiac genetics for a long time. So genetic counsellors see patients and their families who are affected by a genetic condition. So that might mean that you have one, you are at risk of one, or you have a child or a pregnancy at risk of a genetic condition. And there are thousands of genetic conditions. And a genetic counsellor is the person who you speak to about the fact that it has happened, the chance that it may happen again, what your options are, and also looks after your psychosocial well-being along that journey wherever you are. And so when I started that job, I absolutely loved it. Was really interested in cardiac genetics, but really interested in kind of the equity of how that service is delivered for different people around the world and in my clinic. And so there is a very strong connection between what my PhD is about and the experience that I had clinically working with patients.
Wow, just wow. That sounds very awesome. You've had quite the journey. Mm-hmm. I mean, you started out with biological sciences, and then you moved into science communication, and then genetic counseling and cardiac genetic counseling. I think cardiac, that is heart, right? Sorry,
it's heart. Yeah.
Okay. So, in your opinion, what do you think a genetic condition is, or what would you categorize as a genetic condition? Would having a headache be, for instance, a genetic condition? So let me hear your opinion.
Okay, so your genes, your genetic information controls everything about you, how you develop, your hair color, your eye color, but also how you interact with your environment. And it can also be the cause of disease as well as the cause of health, right? So asking if something is genetic, I guess everything about us is genetic, because some people are more susceptible to have headaches than other people, right? Or some people are immune to some conditions and others are not. And all of this is somehow encoded. But that balance of what is genetic and what is environmental is different in different circumstances. So when we talk about what the types of conditions that genetic counsellors see, we're talking about the types of conditions that are strongly encoded in your genetic information in some way and may have some interaction with the environment, but the genetics is kind of leading the risk in terms of that disease. So what that means is we often use descriptions like a monogenic condition, which means one gene. So it means that out of all of the thousands of genes that you have, there is one particular gene that has a glitch or a change in it that is the cause of that problem. And so that's why then we start to talk about conditions like heart conditions, cancer conditions, neurological conditions, eye conditions, where we know that it's one particular genetic glitch or fault that is the reason that that person has developed that condition or is at risk of that condition. How bad that condition will be or what age that condition might start at, those are all things that are controlled by environment in some way. So you could say that somebody has a genetic risk of a cancer, but actually whether or not they get that cancer or how bad that cancer will be due to lots of other factors as well. So in its basis, a genetic condition is any condition that is caused by a change in your DNA, in your genetic information. Yeah. It may not be inherited. So an inherited condition is one where that genetic change is passed on through generations from parents to children. It may be a genetic change that has started for the first time, but in essence, it's always about a condition that is caused by some alteration in your genetic information somewhere. So yeah. Wow. That's why there's so many of them, because we've got so many genes.
Okay. So what baffles me is that it sounds as though most of what you would consider a genetic condition would start from a simple diagnosis, maybe. Maybe somebody is experiencing some kind of irregularities in their well-being, and then they go to the doctor or to get tested for something, and then they realize that this person is ill. At what point does it cross from being, oh, this person is just sick or ill, to being, this is a genetic condition?
So so there are some so we already know, right? So there are some conditions where we already know whether they are monogenic, so these conditions that are serious genetic conditions that are caused by usually one identifiable gene. Sometimes there are interactions with different genes, but we kind of know that there are those types of conditions. And then we kind of know that there are conditions that are multifactorial. So they are what we know are caused by many different genes, many different environmental factors, which means they're really hard to test for. You know, you can't give one single test and say, oh, this is the reason that you have asthma. It's a mixture of all of those things. So if you turn up to a doctor, they're not going to send you for a genetic test for every single condition, because there are some conditions that are clearly defined as multifactorial. So they'll know that, you know, diabetes or hypertension or asthma, these are multifactorial conditions. We know how to treat the symptoms, but we don't necessarily need a genetic diagnosis in order to manage those. But when it comes to genetic conditions that are kind of monogenic or caused by these single gene changes or interactions of much smaller genetic changes or fewer genetic changes, those can happen anywhere in life. So that, you know, when you said, is it mostly people turn up and they're sick? We see people in all different situations. So you may be pregnant, you may have a scan because you're pregnant, and the scan may show a physical abnormality, and the doctors say that physical abnormality often goes along with a genetic condition. So in this pregnancy, why don't we have a genetic test to see if there's the cause of this baby's problem, and then we will know how to manage, what the life expectancy might be, whether there are other problems associated, whether there's something else we need to look at, because this thing is a sign of a genetic condition, and therefore we'll have a test. You may have a lot of cancer in your family, and we know that cancer is really common. Not all cancer is related, not all cancer is caused by a single gene. But if you have the same or related types of cancers in your family, you might come to a genetic counsellor, and I've drawn your family tree and I say, oh, that looks like there might be a singular cause for these cancers. So you may not even have cancer yet, but I may be able to give you a test that says, in your family, you have this singular cause of a particular type of cancer, and here's the advice I can give you about that particular thing. So you may not be sick and have a genetic test, which we call like a pre-symptomatic or a predictive genetic test. Okay. You might have a prenatal genetic test, so one that's in pregnancy. You may, as you described, already be sick. So you may already have a neurological problem. So you may already be like, my memory is going, my motor skills are going, people are noticing changes in my behavior. And your neurologist might do some brain scans, they might do some types of tests, and they say, actually, let's also do a genetic test, because sometimes there are genetic causes of neurological conditions as well. They may have even already diagnosed you based on what you look like and how you're presenting. So they may be like, actually, this looks like Huntington's disease. Let's do a genetic test to confirm it. And that's called a diagnostic genetic test. So sometimes, yes, people are sick. You can already determine what you think the condition is or know the condition is. And the genetic test is to confirm that it was caused by a gene. And the reason that that's important is because it might tell you other things, but also it tells you about the risk to other people in the family who may then be able to have this predictive test before they're sick to know about their status. So genetic conditions can happen at birth. They can happen in childhood. They can happen in adulthood. They can be things that you're healthy, but they can happen in your children. So that means genetic counsellors see people at any stage in life, and you are referred to us by a general practitioner if you're worried and you see a general practitioner, but also maybe by a specialist. So you might have the heart condition already, and then a heart doctor is the person that tells you that you should go and see genetics. So it's quite complicated, in fact.
Yeah. It sounds a lot complicated than I made it out to be, because is it hereditary? At what point is it not hereditary? Can lifestyle influence genetic conditions or create a new genetic condition? Can an upbringing or socio-economic conditions alter people's genetics and hence a genetic condition? Lots of questions around that. I don't know how to wire them into one, but
start with one, and I'll start with one. What was your question? What's hereditary? When do things become hereditary?
We could start from there.
So when you are formed from the egg and the sperm that forms you, you get half of your genetic information from your mother and half of your genetic information from your father. Yeah. They may already have a genetic condition or be carriers of a genetic condition. And so that genetic information that you receive from the day you were born may already have that glitch in it. So that's one way of something being hereditary, okay? And so that means that every cell in your body, because it's come from this one egg and sperm, every time that cell divides, that glitch is divided into your whole body and it's hereditary. You now have it, which means that your sperm or your eggs also may have that glitch, right? So therefore you could then pass it on. Yeah. Scary is a strong word, because remember, I've told you that sometimes you're absolutely healthy.
Yeah,
so
true.
Every single person has 3 or 4 glitches that could cause a serious condition. Wow. But most of us are not sick, right? There's nothing wrong with most of us. Because the only way that would matter is if you have a child with someone who has a glitch in the exact same gene, and those 2 glitches come together in a child. And that's how something like sickle cell is passed on. Because you can have 2 healthy people, but they happen to have the same change in the same gene. And in a pregnancy, in fact, 25% of their pregnancies, this could happen, they pass on that change. So So actually, scary, it's scary if it happens. If it doesn't happen, you can't walk around worrying about what genetic change you might carry, because we all carry them. That's just a normal part of being human. Our genes have mistakes. Which brings me on to the next bit, at which point can you get a genetic change? So you could have it just, because as I said, it's passed on to you. Yeah. And either it's passed on because that person has a condition and then there's a 50-50 if they pass that condition on to you. Right. Or that person is a carrier, which means that they're healthy and they just may or may not pass on the carrier status to you. Okay.
Okay.
So remember, you're only half your parents. So
Yeah.
there's very few genetic situations where because your parent has it, you're 100% going to get that thing, because you're only ever 50% of your parents. So there's usually at most a 50-50 chance that you would get something or not. There are situations where it's slightly different, but for the most part, we're not talking about just because a parent has something, you're definitely going to get it. It's normally a chance that we're talking about. And then the other thing is that when these eggs and sperm are dividing to make all the millions of cells that make us, they can have a glitch at any point, because it's really complicated to make a person. It's really complicated for our DNA to replicate itself, to reassemble itself, to know what to do. And so you could have a genetic condition that wasn't inherited from your parents, but happened really early on in that forming of you. So now you have the genetic change. Your parents never, but because it was so early in your development, you again have the change in most of your body, which means you might have the change in your eggs or your sperm, which means it's now become hereditary, because now you can pass it on to your children, even though you didn't get it from your parents. So there is that. Then there are other genetic changes that happen, and they only happen in a particular part of your body, which means that that genetic condition affects you, but it's not something that you're ever going to pass on to anybody else, because it's not something that affects your sperm and your eggs. So genes they're interesting things. Yes. So I think I've kind of explained that there are different ways of things being hereditary. Not all genetic conditions are hereditary, and hereditary doesn't mean 100% that you're going to get something that is in your family. We're always talking about a risk or a chance. We're never talking about, very, very rarely talking about certainties.
I mean, it puts a lot of my concerns to rest, knowing that even though it's hereditary, it is only a chance, because, like you said, you're only 50% of each parent, right? And so you probably are having a dampening effect from the other parents, and unless you've got AS, which is a very classical example you pointed out, where there's a chance to get like a 25% chance to get an SS child. That puts a lot of things to rest. But the fact that people, given to the fact that the process of becoming a human is a complex process, and then those cells could create a glitch, as we call them, means a person could conjure up a genetic condition even without any, how do I put this? Without any external factor. It could just be a thing of during the formation of that person, they just come up with a glitch.
Yeah. And do you know why that's such an important concept to hold on to? Because one of the really challenging things that we encounter when we talk to people about genetic conditions is that people want to assign blame and guilt to the fact that a genetic condition has happened. And you cannot assign blame and guilt over something that you cannot control. Yeah. And so for most of the people that see us, it's a huge relief often to take away the burden of this was because you did this or you did that. But when we're talking about very serious genetic conditions that have this very strong genetic component, there is nothing that you can do to make that happen or not happen as us. Now, you might have a belief system that means that you have other ways of understanding why things happen and why things don't happen. Yeah. But when we talk about how genetic changes happen, we know that these types of genetic changes, there isn't anything environmental at that point that you could do to make that happen or not happen. Yeah. But that doesn't mean that environment doesn't have an interaction with your genes, which is the other thing that you're asking me. Yeah. What you're talking about is the degree of interaction. So how much of the environment can change the course of what a genetic change can do or not do. And it depends on the gene, and it depends on the gene's interaction with the environment. So if we are talking about, so there's a very serious bowel condition called familial adenosis polyposis, so FAP it's called, and it causes hundreds of polyps in the bowel. And if you don't remove those polyps by surgery, you are almost 90-something+% chance of developing a cancer in your bowel. So if you have that gene, you could eat grass for the rest of your life, but you have that gene, and that's what that gene does, and the environment has very little effect over whether or not that's going to happen. That's just the course of that gene. But you could also have a different genetic change that maybe increases your risk of cancer. And so the exact same environmental things that would cause cancer if you didn't have a genetic change, like smoking or aging, like all of these other environmental things that can increase your risk would still apply. Like they still apply to you, but you're already born with an increased risk. And so that increased risk means that those environmental factors have a bigger impact on you than they might have on other people.
Right.
So it's really important that the things that we can do to lower our risk of disease and improve our chance of health are the same for all of us. But we all have a genetic profile that means that we may be more at risk of some things than other people.
Than others, yeah.
Most of us don't know what that is, so let's just lead a healthy lifestyle. But if you do know what that is, I could maybe give you some advice about the thing that is not going to be a good idea for you. So we know that there are some genetic conditions that increase problems in the lung. So I might say to everybody, smoking's not a good idea. But to you, you've already got a predisposition for problems with your lungs. You're the type of person that shouldn't smoke and shouldn't be around smoke, because I know that about you. Mostly we don't know. There are lots of tests that people sell you that think they can tell you that they know. But mostly there's a lot about our genes that we don't know. But when we do know, then we try to give advice about that.
Yeah. Wow. Again, this sheds more light into my confusion, because knowing that some of these underlying genetic conditions are not your fault, well, most of them are probably not your fault, can play out in two ways. One is that you worry so much because you know you can't change it because you did not cause it. So you can't say, oh, it's because I take a couple of soda in a day, so I need to stop taking soda so that this thing improves. So you get to worry too much that, oh, I can't change this thing. And the other way it could play out is that you are just unbothered about it. Like, I can keep doing whatever I would do, what would be, because I have there's nothing I can do that can change this anyway, so I might as well just continue on a spree of smoking or drinking or something like that. But being able to understand the tendencies, the underlying conditions, and how prone a person is to certain conditions if they lead a certain kind of lifestyle, sort of puts the balance in the equation. Because for me, I would have just said, oh, well, I can't do anything about it. It's similar to you, like the example you made about having that thing in the bowel and needed surgical procedure to take it out. Such a person might think, oh, they need to be eating healthier and healthier, and then they will get better or reduce their risk. Unfortunately, that wouldn't cut it. Such a person might think, oh, because nothing can solve this, I can as well just eat junks for the rest of my life. And that would spill into other conditions that they were not planning for, which I think is more disastrous. But for me now, speaking to you, how do I know what kind of genetic conditions or glitches exist in my gene? Is there a way, is there a one-size-fits-all test that I need to do to check, oh, you have proneness for this, you're good here?
Please don't. Please don't. And this is what I mean about these direct-to-consumer tests that will tell you, we can sequence your entire genome and we could tell you whether you should eat grapes or not. Like, because as you said, like, so there's three really important things that I want to say. So the first really important thing is that all genes have changes, because if they didn't, we would all be clones of each other, right? So when I'm talking about a glitch that causes a disease, it's the same glitch, if my hair was natural, that would have made my hair blue and your hair black, right? A glitch is a glitch. True. Sometimes a glitch causes a problem. Sometimes it just makes us the wonderful, unique people that we are, right? So this is just what genes do. So you can't have a go at genes, right? For changing, and then sometimes it causes a problem and sometimes it doesn't, because genes have to change to give us the variety of who we are, to give some people resistance against some things that other people don't have. So like there's lots of evidence to support that actually being AS is protective against malaria, right? So it's a glitch that persists in those countries because it offers some advantage. Obviously, when we're SS, it causes a problem, but there is some advantage to being AS, and this is why lots of carrier statuses like persist. Lots of these glitches persist because sometimes they have benefits that we don't even really know about. So I think that's the first thing, that nothing's gone wrong because you have glitches and changes. When they're good, we call them variation. When they're bad, we're like, oh, they're glitches, and we just call them pathogenic. But they're just things that happen. We all have variation, like they're just things that happen. So that's the important thing. The other important thing is you said that there are two types of people. There are people who are obsessed, and there are the people who say, oh, I don't want to do anything at all. As a genetic counsellor, I can show positive regard for both of those types of people, and that's the importance of my job. Is that if you turn up to me and you are overestimating your risk, and you are obsessing about what you may need to worry about and what you can control or not, that's what I mean about your psychosocial adjustment. So these are the thoughts and feelings that we are talking about. These are the risks that I will try to explain to you. What's an absolute risk? What's a relative risk? So if somebody says, oh, the risk is doubled, and I'm like, yeah, but it's doubled of 1%. The risk is 2. How do you feel about a 98 positive risk, right? So this is what I mean. So when you're talking about, what would I obsess about?